Okay, it's about 10 after and time we get started. So I'm glad to see everyone here to learn a little bit about Antarctica. And maybe before I start, I'll mention I was talking with Frank Zalem yesterday, and he suggested that, well, obviously we have a lot of faculty that go around the world and go to some amazing places. And yet we rarely, other than the labs that the PI is in, we rarely see anything that they experience. So, obviously you don't have to give a departmental seminar like this, but I think if we can get people to maybe give smaller presentations and sort of make an announcement departmental-wide, I think there'll be a lot of interest. So since I am kind of sponsoring myself for this seminar, I will self-introduce as well for those that don't know me. My name is Michael Perella. I'm professor and chair of the great department of entomology and nematology. And a little bit about my background, just very quickly, and maybe I'll get into how I kind of got into Antarctica as well. So I'm originally from New Jersey. I went to Rutgers University. I have a BS degree in animal science, and then down to Virginia Tech, where I have a master's and a PhD, really in biological control and IPM, biocontrol of weeds, and then working in tree fruit systems. And then in 1980, actually, I moved to the Department of Entomology at UC Riverside, where I was an assistant professor. I was there from 80 through 1988. The end of 88, basically this place actually advertised for a position. I applied for it, and I was very, very fortunate to get a position here. So I started here in the end of 88, and then in 91 I became chair of the Department of Entomology. So I was chair from 91 to 99, and then really from 99 to 2009 I was associate dean for agricultural sciences in the college here, and then in 2009 I came back to entomology as the chair. So my research area really is biological control, integrated control in glasshouses. And what we've been doing recently is looking at soil microbial inoculants to improve overall plant health, to induce host plant resistance, and looking at the impact on that third trophic level. And so it was sort of that research that got me involved with some folks in Chile doing research like that. And then Manuel Guidical has a product from Antarctica, and he calls it Pseudomonas antarctica. And basically I started working with that project, with that product in my laboratory in the greenhouses, and Manuel invited me to Antarctica to do some bioprospecting with him. And so basically I jumped at the chance. It's a place I've always wanted to visit, and I had an opportunity to go. So basically that's kind of the backdrop for this, for the experience and for this presentation. So I'm going to focus, the title here, as you can see, is To Antarctica and Back, the search for Belagica antarctica, which for those that know anything about insects or arthropods in Antarctica, this is the premier one. This is the one that gets all the headlines. And so, when I dug into the literature a little bit before I actually went to Antarctica, what you find, well, anyway, this is the midge itself, before I get into that. It's black, basically. It's wingless, and a lot of adaptations to the Antarctic to survive. It's a harsh place, and I'll talk about that. It's a harsh place to go as a scientist. I think it's even worse to actually live there as an arthropod. We've got the larvae here that sort of clump together. Again, I think it's an adaptation for survival. And this is one of the original drawings that was done of the midge back in probably 1906 during the heroic age of Antarctic exploration. And so you can see that it's wingless as well. And again, this midge is what has got all the press. And so if you go and you Google insects in Antarctica, and I just did this quickly, here's what you find. You find it's the only insect. There is only one insect. The Antarctic midge is the only insect, right? So that can't be true. There's got to be more insects in Antarctica than Belagica antarctica. So one of the things we did was we surveyed sort of around the Chilean research station, and indeed we found a lot of arthropods, and I did find another insect that was there, and I'll kind of allude to that as I go through this presentation. Before I get into the arthropods, though, I thought I would talk a little bit about the continent of Antarctica, and obviously I'm familiar with it from documentaries and from nature films and things. but the idea of actually knowing a little bit about it, I knew very little. So I'm assuming most people, are sort of at that level. So again, I'm going to talk about the continent and about its physical location and some of the conditions that exist there that arthropods and other animals basically have to live in. Then I want to talk about Chilean research just a little bit. I have a major focus on the continent, maybe 11 different research stations. We were at the major one, so I'll talk a little bit about that. And then also, we did a little bioprospecting, and I'll discuss that a little bit. That was the main reason to be at the station, but then I surveyed for arthropods as well. So I'll talk about the search for Belgica and then for its relatives. And I'll focus really more on invertebrates. I found one insect, mostly invertebrates, a fascinating group. There's no question about it. So basically, I'll talk about that, and then I'm going to end with about a 7-minute video that I think, at least the best that I could do, encapsulated the experience. I think I took, myself and Manuel, who was my host, we took over 2,000 slides, I think, of this experience. A lot of video to kind of boil it down to 7.5 minutes was quite a challenge, but again, I'll try that out on you at the end of this presentation. Okay, so Antarctica, right? It's a massive continent, right? It's about the size of Australia. And again, I'm going to talk more specifically about the continent itself in the next few slides, but you can see that this is from Google Earth, a recent photograph. And again, you can see that it's pretty much covered with ice. 99% of the continent is covered with ice. The only place that is free of ice, really, are right along the coastline. And so, in that context, that is where all the action is. That's where the arthropods are. That's where the birds and the seals. That's where everything breeds. So, in that context, it's a very small part of the continent that actually is where you have this sort of biological activity. Okay. So, maybe taking another look at it in relation to the land masses that are near it. Right, so we have Antarctica here, obviously. You've got Africa, Madagascar. Here's Australia and New Zealand. And then you have South America. So you can see the proximity between the southern tip of South America, Chile and Argentina, and Antarctica is very, very close. So this is pretty much the launching pad for a lot of expeditions into Antarctica, and that's where we originated as well. We started in Punta Arenas, which is here, and basically where we were was in this little archipelago right here that is actually the northernmost part of Antarctica. So the northernmost part means it's the warmest, and that's a relative term. And at the same time, there is the greatest biological diversity on the entire continent there, so it's an excellent place to survey. And I'm going to show more, obviously more pictures and a few more maps in the next few slides. Okay, a little bit about Antarctica, right? And it is without a doubt the coldest, windiest, driest place on Earth. 2/3 of the planet's fresh water is locked up here in the form of ice, and again, it's the size of New Zealand. So, there's just some remarkable statistics, right? It is also the world's highest continent. The average height in Antarctica is 6,500 feet, and I think there are mountains there that go to over 16,000 feet. As I mentioned, ice covers 99% of the land, and only the coast is available for birds and for mammals for breeding. The mean annual precipitation is less than 5 inches. It all falls as snow, and so this perpetuates this polar desert. I mean, it's really remarkable, a remarkable place. It is the place of the most active glaciation in the world, and temperatures in the winter are 25 degrees below zero, and during the summer, it's at the high of 0 degrees, 32 degrees. Remarkable. And I guess the thing, 32 degrees sounds okay. Sounds like it's okay to exist in. But the remarkable thing about Antarctica was the wind. And it is constantly windy. 5, 10, 15, 20 miles an hour. And anyone that knows, you have 32 degrees and you have 20-mile-an-hour winds, that, I don't care how many layers you have on, it basically sucks the warmth right out of you. We had winds upwards of 40 miles an hour and almost always some sort of precipitation. I think we were there for almost 3 weeks. I think we had really 2 days of sunshine. And so in that context, it's always cloudy, it's always sleeting or snowing, and it never comes down straight. It always blows pretty much horizontal. So, in that context, an amazing place to do work as a scientist, an amazing place to survive as an animal or as as an arthropod. A little bit more about the winds, right? And they're famous in Antarctica. They're called Kabato winds, basically, and they roar down these glacier valleys up to 120 miles an hour. And the position of Antarctica relative to the Arctic, I think, is interesting in itself, right? So unlike the Arctic, which is surrounded by land, the Antarctic is surrounded by the Southern Ocean. And so that makes a completely different scenario for sort of the mixing of currents and air movement as well. So between latitudes 40 and 65 degrees south, which is pretty much about as far south as you can go, there's uninterrupted wind that circulates around the continent. And basically, and these are called, this is the west wind drift is what it's called. You've got the roaring 40s, the furious 50s, and the screaming 60s. So again, it's an amazing place from a wind perspective. So that's sort of the wind around the continent, but then sort of around the oceans around the continent. But then around the continent itself, there's a contrary circulation. So there's winds going in a different direction. And so basically this is called the east wind drift. And so you've got these winds and you've got these currents, so it basically creates an environment for incredible turbulence. So some of the roughest oceans in the world exist here. The Drake Passage between sort of South America and Antarctica is considered the roughest ocean in the world, but it's also a very rich environment for mixing. And so in that context, there is a tremendous diversity of species in that area. I think more than 8,500 species have been found in the ocean. And obviously the most famous inhabitants certainly are penguins, whales, and seals. And you know, what I put here was that they're beginning to recover. And I think anyone that knows anything about what has happened in the Antarctic is that it was ruthlessly exploited, right? In the early 1900s, 1920, 1930, 1940, basically seals, the first seal almost went extinct. Huge pressure on whales as well. They exploited penguins for their oil and for their feathers. I mean, it was just a slaughter, absolute slaughter. And so basically there is now there is a treaty that's been signed, the Antarctic Treaty. All the countries that sort of do research there have sort of agreed to sort of preserve the place for scientific investigation. Hopefully it's not too late. Again, I think a lot of these things are recovering, but it's still, they still have a ways to go. There's two things that are still harvested extensively in Antarctica. One is whales, primarily by Japan, and the second is krill, and I'll talk about that in a second as well. Excuse me for a second. Okay, I'll do another map here, and the reason to put this up really is to show this amazing, this is the Antarctic Convergence Zone. And it looks like it's kind of flexible, but actually it's quite consistent. And what this is sort of the mixing of water from the Antarctic. And you imagine this is all ice, it's all fresh water, it's melting, so you end up with most of this being, it's salt water, but it's really dilute, got a lot of fresh water in it. And obviously it's very cold. So here you've got an ocean that is typical, salty and fairly warm. So when you get these two that come together, you've got this very distinct Antarctic convergence zone. And so it is a zone that is very well delineated because there's fog there as well, as you can imagine. It's also an incredibly rich area for marine life. I mean, it is absolutely spectacular. And I guess the convergence zone dictates what is in Antarctica and what is not. So if it's outside the convergence zone, it's considered not Antarctica. If it's inside the convergence zone, it is considered to be part of the Antarctic. So, you know, for those that can see, you know, this is the Falkland Islands right here. And everyone knows Argentina claims it, so does England. There was a war a few years ago. The Falkland Islands, as you can see, is kind of outside that convergence zone, so it's not considered part of Antarctica. And here, which is where we were, sort of the King George, South Shetland Islands, it is inside that convergence zone, so it's considered part of the Antarctic. And again, this is the notorious Drake Passage right here, which does represent some of the most turbulent ocean in the world. And maybe I will point out one more thing. This is Elephant Island right here. And for those that are familiar with Shackleton's famous voyage on the Endurance, an ill-fated expedition, he basically left his 24 men on Elephant Island for 4 months while he was in Punta Arenas in southern Chile trying to arrange an expedition to rescue them. I think he had at least 3 failed expeditions before, you know, basically he was able to rescue his men. So again, this is the area where all that pretty much all that activity for his expedition took place. Okay, just one more slide, the last one in terms of a map, and again showing sort of Antarctica and South America. And I put this up because even though Antarctica is considered to be a continent by itself with no claims to it, you know, certainly there are many countries that sort of have different pieces that they feel belong to them. So Chile and Argentina, which are obviously are the closest to Antarctica, sort of have claims. And what I did here in red, which is the easiest to see, this is Argentina, and you can see sort of the piece that they sort of claim in Antarctica. At the same time, this overlaps with some of Chile's claims, so it's kind of crazy. But for the most part, I think Antarctica is left alone. It's not to be used for sort of military operations. It is there's no drilling or mining that can occur there. It's really for scientific investigation. It's also a place for remarkable camaraderie among scientists, and hopefully I can impart that to you in this presentation. Okay, just a little bit more. During this heroic age of Antarctic exploration, right, which occurred in the late 1800s, early 1900s, an amazing number of zoologists would go to the continent, and they described everything. Literally, it was almost a furor over just describing new species, basically. So whether there's anything new to actually find in Antarctica remains to be seen. I'll talk about some of the things that I found there, and they still need to identify them. But you know, the idea of having something new probably is not the case. So 30 countries have signed this Antarctic Treaty, and basically they operate seasonal and year-round research stations on the continent. So the people performing research there, generally there's about 4,000 people there during the summer, and there's 1,000 hardy souls that pretty much stay in all those research stations over the winter. Obviously, we're talking about the South Pole, so when we were there, we had maybe 20 hours of daylight, very little darkness. It's just the reverse during their winter. There's very little light. Again, it's mostly dark. The temperatures are incredible. The wind is incredible. It is a harsh place to live. So I just wanted to put up here that this is specifics about the Antarctic Treaty that I'm not going to go over. I've already talked about that. And these are some of the countries basically that have signed that agreement. And again, there is remarkable camaraderie between them. So at the Chilean Research Station, which is named after Professor Escudero, and he basically is a pioneer for the Chileans in terms of Antarctic research. At the station, there is this bronze monument, I guess, to those who have signed this Antarctic Treaty, and all the countries are listed here. And I just zoom in on one part of it, and I will read it. And here's United Kingdom, New Zealand, Australia. This is the United States. In honor of the Antarctic Treaty and those who support it, who have so successfully cooperated in the study and preservation of Antarctic as a world treasure, 1959 to 1999. I think they need to sign probably a new agreement, and I think that's in the works. But again, it does speak to the fact that it's looked at as a world treasure, and everyone seems to be cooperating. Okay, so the unique thing about the Chilean station is that I said one thing about it. It's one of the farthest north of any of the research stations, so it's in an area of rich biological diversity. At the same time, it's also, you know, very close to other research stations, and we're able to visit some of those as well, and that in itself was fascinating. So this is a map, if you will, of King George Island, which is where the Chilean station is located. And this is where we sampled sort of on this island. So here is the Escudero Chilean station. Right here, right next to it in the same sort of bay, is the Bellenhausen Russian research station. Then here's the airport here. So you land here, come down to these two stations. Then there's a road, and actually you can walk this road if you are brave enough, basically, and you come down here, and this is the Great Wall Station that China operates. So we visited that as well. And I don't think many people visit these stations, since they really fall all over themselves to show the place. They feed you when you're there. I mean, it was very, you know, very interactive, very positive. And I'll show a picture of the Chinese station in a moment. Okay, then you can take this road, and here you can't really walk it. We have the Chilean station maintains what they call a worm. It is a large tractor with treads, basically, that winds its way over this road, and as you go all the way up, unfortunately it's not here, there is a research station manned by by Uruguay. So there's that research station as well, and we visited that. There's also the Korean research station that is here as well. So again, it's an area rich with biological diversity with a lot of research stations at the same time. So this is just a view of the Great Wall Station. Very, very nice, relatively new. These are all marble basically, and they have the bell here, and you know, just a beautiful station. This is one of the research technicians that went with us on the trip. And again, I just wanted to show the sort of the camaraderie here. This is a Chinese station, and what they've got here basically are all of the flags of the countries that have research stations that are in near proximity. So again, very open with the research, very hospitable. Same thing with the Uruguay station. So, you know, a very rewarding thing to see that sort of cooperation taking place. Okay, now moving in and being more specific about Chile, right? So this, I stole this slide from the research station. There was an international Antarctic scientific sort of conference that took place in Chile, and they used this as sort of the creation of Adam, right, that everyone's familiar with, and they superimposed South America and Antarctica here. I'm sorry. So, you know, basically looking at the proximity, and a lot of research going on in Chile is to look at the geology, basically, and sort of the geological events, and also the fauna as well that occurs between Chile, Argentina, and Antarctica. So this is the archipelago itself, right? This is the Antarctic Peninsula. And so maybe you get a better sense that it really is a peninsula. There are a lot of different islands here, basically. And where we were located, the Chilean Research Station is right here. So and these are all actually stations maintained by Chile, but the Escudero Station is the largest one. And just as a reference point, I believe the Palmer Station, which is the famous U.S. station, is located right here. And so this is not a trivial, it looks like it's close really, but it's not a trivial distance. It may be as much as a 4-hour plane ride to actually get there. So again, the Palmer Station, a lot of work has gone on there, but again, it is significantly sort of farther south than the Chile station. So where our expedition started was at INACH, which is the Antarctic Chilean Research sort of Institute. This is a white building in downtown Punta Arenas, which is the you know, sort of large city in the port city in the southern part of Chile. We actually spent 2 days in Punta Arenas, and we got outfitted there. So basically, they gave us some of the clothes that we would need to survive, and then also, you can't just go to the research station and not have some understanding of what to expect when you're there. So basically, we sat through a presentation where they talked about sort of the do's and don'ts about going to the research station. This is just a close-up again, the Antarctic Chilean Research Institute. So you get to the research station, and this is a view from the main building looking out at the bay. And so basically, you see some of the buildings here. The Russian station is here. You know, it is absolutely spectacular. And on a day when there is actually sunshine, which usually occurred, if it did occur, it was at the end of the day, and that's when this photograph is taken. You can see there's a massive glacier out here as well across the water. You know, just a truly spectacular spot to spend 3 weeks. So this is the physical station itself. And again, it's Escudero Station, basically named after the professor. And again, there is satellite communication here, internet and phone. You know, not particularly good. I would say. I don't know what you can really expect there, but in a sense, you could communicate, so that was okay. This is a research lab here. That basically, as research scientists, you could actually rent space here, and that was part of sort of a contract with the station. And then we had sort of this is where there's a upstairs is where we ate, basically, a little recreation area, some area for sitting as well, and doing working on your computer or working on presentations or analyzing research data. Sometimes, I think maybe 2, 3, 4 days, we were not allowed to go outside, because the wind was 40 miles an hour and we had incredible snow. So in that context, from a safety perspective, it didn't make any sense. So you need to bring a book to read. You need to have something to occupy your time, because you can't, you know, always access the outdoors. it truly was a melting pot of scientists, and that's what I'm going to try to show on the next slide here. And I realize you can't see it, but basically when you first get there, there's a whole group of us that went. You know, they have to assign dormitory rooms for everybody, and it's not a trivial thing to kind of match people up. But so just very quickly, so in our group, right, when I was there, we had folks basically from Chile, from Venezuela, from Holland. They were from Poland. They were from Korea. Obviously, we had the USA. We had France. We had Brazil. We had Germany. And we had Australia. So all these scientists together in one place, all doing different things using that Chilean research base as a base of their operation. I took this photograph because it's remarkable. Each one of these individuals comes from a different country, and yet they're part of a constituent of scientists that are there to study moss and lichens in Antarctica. And this gentleman, Todd, is from Portland State. He's an expert on sort of volatiles coming from moss. So he was there. We have Germany, we have two from Australia, we have France, and then we have Brazil. So again, just it's quite a group, and being very interactive, and you get to know everyone at the station. So in that context, again, speaking of it as a melting pot, it was really, really remarkable. Okay, now we're going to get into a little bit of the life in Antarctica. And again, when it's sunny, the color is outstanding. So this is sort of a view of what the moss and the lichens look like. And obviously there's snow melt here. And I put a little bit of information about the diversity of plants. We have 300 species of algae, 200 lichens, 110 mosses, 25 liverworts, and 2 flowering plants. So I don't think we'll find Neil Williams there looking for pollinators, but nonetheless, there are 2 flowering plants. They apparently don't produce seed, but they do flower. Deschampsia is one, and Colobonthus is another. And Deschampsia is the one that Manuel and his company, Creative Biosciences, is looking at, both for secondary plant metabolites as well as for sort of microbial root products that he can, in a sense, use for agricultural purposes and for medicine as well. Now, talking quickly about Chilean research, and I alluded to a little bit of what Manuel is doing, they're very proud of what goes on in Chile. So they have a number of publications. This is one that talks about advances in Chilean Antarctic science, and they talk about each of the projects that have gone on in the past year. And these are the 7 areas that are actually emphasized for research. And again, I'm not going to read all of these. You can see them for yourself, but obviously climate change is one. And where Manuel and I was involved in was in number 5, which was Antarctic microbiology and molecular biology. And Manuel, who is here, basically has a grant, and you can see the name of it here, that's funded by ENOSH and other groups in Chile, primarily to do bioprospecting, to look for, again, secondary plant metabolites or microbial root inhabitants that, again, you can potentially use for both medical purposes as well as for agricultural purposes. And I thought I'd show a quick slide of one of Manuel's companies in Chile. This is Creative Biosciences, a beautiful lab, very, very well equipped. And he raises, that's just Deschampsia, that one flowering plant, in some of his growth rooms here, so he can look at it and, again, study it and look at secondary plant compounds and other products that are potentially associated with it. So this is the plant itself, basically, that we were looking at, taking clippings, looking for secondary plant metabolites, and then, being very careful, but digging up the roots and looking for microbial inoculants, microbial inhabitants of the root zone. The experience was spectacular. So this is where we stayed, right? We stayed at, this is Collins Glacier, which is sort of north of that Chilean research station. We had to take a Zodiac to get to it. This is Collins Glacier, basically. Penguins everywhere here, and you will see a video of that in a few moments. So this is the habitat. It's called the habitat. It is not. I guess if you look for a mint on your pillow in the evening, you're probably not going to find that. But nonetheless, it was sufficient. There was a kitchen, there was a place to eat, and there was a place to sleep. And there were 3 of us there as well. What was good was that the bathroom was outside, and that's what you see here. And so the bathroom, I mean, it was remarkable how effective this little tent was at cutting down the wind, which was the big thing to deal with. But a spectacular spot to spend 3 or 4 days, just in a sense doing bioprospecting and looking at the wonders of this whole area. Just another photograph of the the habitat. And I won't show inside, maybe that'll be for a separate presentation, but to say that it's cramped is an understatement, but I think just the idea of being able to stay there, and I will say that when they turned out the light, it got cold. There's no question about that, but we had, we were well equipped, so we had no issues with that at all. Okay, so here we are doing a little bit of bioprospecting, taking some samples, and I show that in the video as well that you'll see at the end. And then Manuel gave a presentation yesterday. A number of people were there. And basically, he came up with this product called Eco Plus, which is a Pseudomonas antarctica that he believes is responsible for enhanced root growth and root architecture, maybe other benefits of plant health. And so basically, he talked about that yesterday. And then in my greenhouses now here in Orchard Park, we have an experiment set up here where we're rooting these plants and we're exposing them to different concentrations of his bacteria with the idea of sort of documenting some of this evidence. And again, that work is ongoing in my laboratory. One of the very positive things about the station is that they really focus on education. So they did have ENOSH, which is the Chilean Antarctic Institute, sponsors a science competition for high school students throughout Chile. And so they bring them down in waves. So basically there were 16 students and 4 teachers that came to the station, and they spent about a week. And they interacted with each of the researchers, and Manuel and myself, we gave them a presentation. It's a little scary to think that I'm an expert on Antarctic invertebrates when I've only been there for 2 weeks, but nonetheless, no one else really knew much about them. So in that context, the students were really eager to learn, and this is a photograph of the students. Amazing thing about it, there were 16 students, there were 14 women and only 2 men. So again, speaking to, maybe a good for the future of science in Chile. And then many of the students, after I showed the slides of the different arthropods, many of them came out with us, and we basically went out and looked in vivo, I guess, of the arthropods that I showed in the slides. Okay, one of the most important, obviously, arthropods in Antarctica are krill. And so there were 2 scientists there at the research station from Scripps, right, from down in San Diego. And they were studying whether the harvesting of krill would affect the fitness of penguin colonies that feed on krill. And there was no question in their mind that there was an impact. They had a paper coming out. We talked about that. It's very difficult to measure that, but they were able to do that. And again, it speaks to the fact that there still is maybe exploitation taking place in the Antarctic. So those that do spend more money at Whole Foods, it may be worthwhile, because obviously that's one place that has banned the sale of krill as a health food. Okay, getting into the arthropods now and what they face. And obviously you already have a pretty good feeling for that, but I thought I'd spell it out here. We've got the incredible temperature extremes. We've got high winds. You've got a very short growing period. Huge swings in pH, right, ranging from 3 to 12. It's amazing that most of the arthropods that we found are associated with penguin colonies. And so penguin colonies there's guano everywhere. It's very fragrant, there's no question about it, but it also is everywhere, and so consequently you can imagine the effect that would have on pH. A lot of the arthropods have to deal with both fresh and salt water, depending on where they're located, in terms of melting glaciers and then tides and waves coming in. They have to deal with dehydration from exposure due to the dry winter air, intense UV rays, and basically lack of oxygen if they're under the ice and under the snow. So we're talking about a select group of arthropods able to survive in some incredible conditions. So there were 4 groups that we found. Okay, the first were leeches. I'm going to skip over that because that's a little too far from arthropods. But then we did find mites, which obviously are arthropods but not insects. We did find collembola in great abundance, and there was an association between collembola and mites, and I'll talk about that. And then, of course, I did find a midge as well, which was pretty exciting, and a different one than Belgica, and I'll talk about that as I get towards the end of this presentation. So one of the most famous spots to visit, which is right across from the Chilean research station, is the Adderley Peninsula. And so it is a very famous penguin colony, and you need a permit to go there to collect, and we did have a permit. So basically, you see the penguins, they walk up here, and you'll see that in the video as well, and they kind of congregate on this bluff. But then if you look at the rocks, basically, along here, the diversity of arthropods there is simply, the numbers and the diversity are just incredible. So there was an individual there from England who was actually was there with the moss group to photograph mosses. I convinced him to kind of come out with me, and we'd photograph some of the arthropods. So here you can see our setup here. You can see the penguins right here and his setup. And if you see this, right, if you look closely at that, it looks like maybe it's detritus or just debris, but in fact those are mites, and they build up in these large numbers under these rocks, and they clump together as well. So if we look at this, you know, the number here, it's just incredible all together. Some of them are dead, but a lot of them are alive. Look a little bit closer. Again, you can see these mites, obviously they are dark, so they're well adapted for this environment. You can see there's one, and maybe there's more than one, but there's one columbella, at least in this photograph. We took them back as well, put them under a microscope, and they do really clump together. I mean, you have to really tease them apart, and I just put another photograph here just to show what was a heavily sclerotized adult, and maybe two that are not quite as mature. Now, my best guess is that this is what we're dealing with here. The Solasoidea, basically, Antarcticus, a non-parasitic mite that lives under the rocks in the Antarctic Peninsula. Pretty well classified, described a long time ago, as you can see. Dark coloration absorbs heat. Almost all these arthropods are able to supercool themselves but using a variety of mechanisms, so they don't basically freeze. Very little is known about the biology of this mite. The literature indicates a 5 to 7 year development time, which is long for mites. It eats moss, algae, and fungi. There are 4 subspecies that have been described. And it's amazing, it's a mite. You know, I associate mites usually with a greenhouse or with tropics or with high humidity. You know, this mite can survive with no humidity and in really sub-freezing conditions. I mean, just remarkable adaptation for that. And getting back to that penguin colony quickly, this is snowmelt here. The penguin colony is off on the left. There are phenomenal populations of columbella in this moss and lichen. And so basically, as we all know, columbella have these hydrophobic hairs. When they get on water, they can float. So basically, these columbella would sort of come down these, this glacier melt, if you will, and they would build up at certain points where the current would stop. And so if you look closely, you know, you can find these rafts of columbella that are building up. There's some cast skins here as well as adults, and we can take a closer look at that. And again, you can get a feeling for what is there. And then it'll go a little bit closer. And you notice something else right on top of these columbella, and those are reddish mites. And so, you know, exactly, I think I may have an idea for what this is, but, you know, at the same time, it needs to be identified. So I've collected all the specimens that I'm talking about here, so we'll see how that goes. But I think we have another, to get a little bit closer. And again, it's a spectacular mite. Looks like a European red mite or a citrus red mite in a sense. And so whether this is a phytophagous mite, this could be a predatory mite as well, feeding on columbella. I mean, that is a possibility. I also looked for columbella in the moss and lichen among the rocks, basically, in this area. And I found another a reddish mite. And I haven't got as good a photograph of it, but you can see it here. Now this one to me, I mean, very rapidly moving. This one to me seemed to be, I would guess that this does feed on columbella, although it's hard to know. It looks a little different than the one that was on the columbella rafts that you saw in the previous slide. So we may be dealing with 2 different species of mites in this situation. There is one publication that actually came out of the British press, and they call, as you can see the title here, they call it the most fearsome predator in Antarctica. And so what they're referring to is a mite, this Ragdia mite, which I couldn't find any information on really, with the idea that it's a reddish mite, feeds on columbella. Chances are that may be one of the 2 mites that I found. But again, we need to dig into that and do a little bit more, at least literature search. Little known about its biology associated with columbella, found in cracks and crevices. It is a voracious predator. There's a British project ongoing looking at this predatory mite. Okay, getting back to Belgica, I'm almost done with my presentation. Again, one of the original sort of drawings, I guess, of the species, and it is a famous midge, right? The Antarctic midge. If anybody knows anything about insects in the Antarctic, this is the one that everybody seems to know about. It's been studied extensively, a number of publications, and here you can see information about sort of the physiology and its ability to tolerate freezing conditions. And Dave Denglinger, those who know know Dave, he's former chair of entomology at Ohio State, National Academy of Science member. He did a lot of work with this midge. Basically, I did communicate with him before I went to Antarctica. He would love for me to send him some midges if I found them. We found a different species. He's eager to look at that as well. We'll see how that goes. But a little bit about the midge, right, and how it is able to survive before I talk about the one that I did find. Some interesting aspects, right, of this midge is that it has so one of the things Dave Denglinger did was to sequence its genome, and it has the smallest insect genome as of 2014 of any insect. So that in itself is intriguing. It can survive freezing. You know, basically it's able to deal with thermal buffering, which is more of an environmental sort of partitioning. It has the ability to accumulate trehulose and glucose and other products to sort of keep its proteins intact and keep it from freezing. I mean, it's just amazing. It's able to resist partial desiccation, surviving the loss of up to 70% of its body water. So certainly an amazing animal. And I was hoping to collect it. I didn't find it. The one that I think I found, is on this slide, is this one. This Parachilis, and basically it's much less well studied than Belgica, and I'm not even sure if this is the right species. So I've contacted Pete Cranston, who, as everyone knows, is the world expert, a chironomid systematics person. He doubts that's what this is, but again, I thought I would show this. We still need to confirm this in the identification of some of the other arthropods, but it has wings. You can see the larval stage here. Basically, it probably doesn't fly, and I'm going to show a video of it in action in a moment. So this is the midge itself. You can see a male to the left, and then probably a female at the bottom and a male on top here. And I'm going to show a video, I hope. No sound. Oops. Okay, this is midge movie number 1. This is habitat. This is a snow melt coming down, basically. This is a research citation. These are all penguin quills from penguins. Okay, so again, these midges are associated with penguins. You can see them here in the sort of on the face of the rock that come up. It's obviously they're in the sun. They've got to, because it's 32 degrees here, if that. And now my attempt at a video. And again, you can see that they are pretty frantic, I think. They really don't have much time. They need to be able to mate and lay eggs very quickly. So a lot of the activity when the adults do emerge is occupied with mating. So just a few moments here of this video, and then it'll be finished. And so again, I'm trying to hold the camera and do this, and I felt that I was lucky enough to get these shots, I think. Another habitat, this is a Chinese station in the distance as well. And here we've got the midge. You can see the male there with the really upturned abdomen and some claspers. And I love this one part. This midge kind of skates around here. Obviously hydrophobic hairs on its feet. You'll see that in a second. There it goes. See a male and a female sort of dragging each other along there. And I think that's about it, I think. Yeah. Okay, so we are in the process of getting all those identified, and we'll see what we've come up with there. I'm going to show the video now, and I think before I show the video, it's important to have sort of a penguin prompt here. And so what's remarkable is that January 20th of last week was Happy Penguin Awareness Day. And so this is a caricature of different penguin species around the world, and there are 3 featured in the video. The star clearly are the Gen 2 penguins that you see here. You'll also have, there's a star appearance by a chinstrap penguin as well. And then you will also see the, where's the Adelie penguin also. So all 3 of those. So again, it's 7.5 minutes. And I think it encapsulates the Antarctic experience for me and for Manuel. I'll say a couple of things about it. First, it starts off in Punta Arenas. at the Dreams Hotel, which is where we stayed. You'll see Enosh, you'll see the headquarters. There's also